Hello world, welcome to my new video, and in today's video we'll write the program to count the vowel from the string and display the count in the screen. So suppose if the user input, suppose let's check my name. So if the user inputs this string, then the programs will count the number of vowel and return in the monitor. So the vowel are, so the output should be 2. So this is the program. So let's start. Before going to the program, I would like to request you to watch my previous video on DOS interrupt. If you don't watch that video, then you will face problem while understanding this video. I have explained the int21 DOS interrupt in that previous video, so watch them. Now let's start. At first, let's write some formalities. Now we'll be needing some stack operation, so we have to define stack. Okay, these are all the formalities for the assembler. I have described them in brief in explained way in my first video of 886, so please watch them out. I'll put the link in the description or card so you'll understand them in better way. So now we have to define or write something that will take the input from the keyboard. For that we have to write paralist label byte maxlen db 20. Okay, from here the program will know we have to take the input from keyboard. So this is the same as like declaring the array. For example, you used to declare array by writing int arr 20 in C programming or any other programming language. So if you write the array this this code, it means the name of the array is arr and the 20 is the maximum length. You cannot leave this like arr this. You can use by using dynamically, but if you are using static, then you have to define the maximum length. So the variable name is maxlen and the maximum length is 20. Now actuallen db question mark. This variable actuallen will keep the actual number of the character entered by the user in this variable. So we are unknown about that for now, so we keep it question mark. Let's declare the next variable. Okay, this kbinput variable will keep the input from the keyboard, and the dup dollar will place this dollar or the garbage value in that 20 memory block or in the 20 block of the array. So this is the initialization of the array. Now we have to compare the each string with the vowel. So let's define the vowel by using the vowel variable db, and vowel are aeiouAEIOU and also in capital aeiouAEIOU. So these are the vowel. Now suppose we have to display some message in the screen like please enter the name or please enter the string. For that, let's keep that message in some variable like prompt db input name. Dollar indicates the end of the string, like in C programming or other we have \0. For this case we have dollar. Now this is the initialization part. Now the main code segment starts from here. We will be using subroutine so that our program will become much more easier to understand. So main proc for I have explained this all about assembler directive in my first video, so please don't forget to watch them. Now mov ax comma @data mov ds comma ax. Here we are initializing data segment. I have explained this in my first video. Now we have to call the subroutine. Cal call. Let's name that display underscore msz. This subroutine will call the this line will call the subroutine to display message like input name. Now let's call the another subroutine to read the string from keyboard. Next subroutine to count the number of vowel, and next subroutine to display in the screen. That's the calling. Now we have to terminate. For that we have the interrupt mov ax comma 4c00h int 21h. So this part will terminate or gives the control back to the OS, because we are running the program in DOS interrupt DOS. So this code will bring back the control to the OS. So this is our part. Now we have to write subroutines. So at first let's write the subroutine for display message. For that we have to use display underscore message proc. So in this way you start the subroutine. Now in my previous video I have explained about the DOS interrupt. So if you want to display the string, that is to display string, you have to use 09 in the AH. So let's do that. For that we have mov AH comma 09. Now we have this prompt variable and the string. Actually this is a kind of array. I think you are familiar with the string. String is actually an array. So let's assume this is the prompt array, and our message like our message to this is our message input name is placed here. So at first we have to point some pointer in the first location of this array. This is the offset address. This pointing to this array means we have to point to the offset address of this array, that is prompt. So suppose this is the prompt, this whole part is prompt. Now we have to point some register to the offset address of this prompt array. For that we have the instruction LEA. This means load effective address. Load effective address means we'll load the offset address. Now to display message we have to keep the message or the pointer to the message in dx register. So let's do dx comma prompt prompt. So this line will bring the offset address of this prompt in the dx register. Now that's all. We have to use int 21h. So this line of code will display the message in the screen. Now we have, since this is the subroutine, we have to return by using ret. Now we have to end display underscore message endp. This is the first part of our subroutine. Okay, this video will be longer. It is already 9 minutes, so I want your full concentration and watch this video carefully, because this is one of the important aeiouAEIOU question. If you can write this program, then you can solve any other question. So let's move to the next part. Now our next subroutine is to read. We have completed this. Now we have to perform this. For that we have to write the subroutine read proc near. Okay, now to read or input a string, we have to use 0a in the AS register. So mov AS comma 0a h. Now okay, let me write first lea dx comma paralist int 21h. Okay, we are using 0ah in the AS register, so to indicate input of string. Now as like in the previous part, we have bring this effective address in the dx register. So in this case, we have to bring the input from the keyboard to the, we have to read the input from the keyboard. So we have to use this paralist because we have defined the paralist here. This will keep the inputted characters, so we have to bring that character in the dx register so the interrupt can read them. Now we have to return the interrupt and in this subroutine. So in this way you will read the input from the keyboard. Now the next is count. Before writing the code about how to count the vowel, let me explain that. Okay, let's take the string as PAWAN. Now we have vowel A, E, I, O, U and A, E, I, O, U, because user can input any string in any case, that's uppercase or lowercase. At first we take this string, suppose we take this string in any register. Now we have to compare this with A. Now if the comparison are equal, then we'll increase the count by 1. We'll keep the count in some register, I'll show that in later. Now if the comparison matches, then we'll increase the counter, otherwise we'll check the same string with E. Now we'll continue all this count until the counting reaches here. Okay, there are 5 vowels, that is 1 2 3 4 5, but considering uppercase and lowercase both, there are 10 vowel, that is 0ah. This is the count of vowel. And now we have compared P with these 10 characters, and if that was vowel, then the count was increased. Suppose count will be increased, otherwise we'll bring next character A. Again we'll compare this with all this vowel, and if it matches, then we'll increase the count by 1, otherwise we'll again bring this, next time again A, and at last N. So we have to compare this all 1 2 3 4 5 with each of them with this 10 character. So the count of the main string will be as much as the character present in the string, that is 1 2 3 4 5 in this case. So each 5 of the character will be compared with this 10 of the character. So that's the logic how you will count the number of vowel. Okay, and remember this string is present in the kbinput variable, and this variable are present in vowel variable. Okay, we have to point at first in this part and this part by using the offset address of kbinput and offset address of vowel. To bring the offset address of the kbinput or vowel, we can use lea, that is low effective address. So I'll show this in the program. So let's create new subroutine count proc near. Now we have to bring the offset address of this input so that we can get access to the first character of the kbinput variable by using lea si comma kbinput. Okay, this consists of the offset address of kb input. Now in our program we have defined actuallen db question mark. That means this actuallen variable will consist of the how many character are consist the value that is how many characters are present in the array. That is, in this case we have five character, so this actuallen will consist of 5. For that we can use bh comma actuallen. So actuallen consists of the number of character that user has inputted, and then that value will be copied to bh register. Now we have to place the counter move dx comma 00s. This is the counter to count the number of vowel. Okay, now this si will pointing to the first character p. Now we have to use other register to point to this vowel a. For that we can use lea di comma vowel. So si is pointing to the inputted string and di to the vowel. Okay, now we'll loop this part 5 times, and this count is present in actuallen variable, and we have to loop this part 10 times, and the count is 0ah because there are 10 vowel. So we have to load the counter bl comma 0ah. Okay, this is the counter to which will loop the vowels. Now both si and di are pointing towards the vowel and character inputted by user. Now let's perform move b al comma si. That is, si is pointing to this first character, and we are copying the value of this character in al register for the simplicity. Now we can compare al means the content of si. This bracket means content of si means the character, this character, it is pointed by si. Now we have to compare al with vowel is pointed by di, al comma di. But content of di consists of offset address, and the square bracket denotes the content of di, that is aeiouU and capital aeiouU. Now if they are equal, that is if the first character inputted by user and the first vowel, that is a, if they matches, then we have to increase the counter. If they do not match, then we have to increase this count by, that is we have to increase the pointer to the e. So jne, jump if no equal to some level, that is forward. If it is not equal, it will go to level forward. So if the character is not vowel, it will move here. If the character is vowel, then we have to increase the counter. We have to increase the counter by using inc dx, because dx is keeping the count. So if the character is not vowel, then it will come here. Now we have to increase this part. inc di means we are pointing towards this location, because this was pointed by di pointer was mentioned here. Now we have to increase this part. Now we have to increase this part until the counter 10. This is the counter until this becomes 0. So incdi. Now we have to decrease this counter BL, and if it is not 0, then we have to go back. This is the label, and the back label is now. If the counter is not 0, that is, if other vowel are also remaining, then we have to again compare the same SI with the another DI. I think you understood. Now, so we are comparing the SI, that is SI is copied to DL. Now we have to compare, we have to do comparison again. Now this loop will run for 10 times, and if vowel occurred, then the counter will be increased. Otherwise we have to increase this part. Now we have to place the pointer in this part. For that we can use INC SI. Now the counter of the SI, or the counter of the character inputted by user, is kept in BH register, actuallen. So we have to decrease DC BH. Now as usual, JNZ jump if not 0, back 1. This is the label, and back 1 will be in now. If the loop of the P part is completed, now we have to start the loop to compare A with aeiouU, that is all this vowel. So we have to start the counting of comparison of the second character with this all. So we have to start this array or this loop again. So I place this label here. Sorry, this should be kept here. So again the vowel counter will be started, because I have placed this label in this part. Now counting will be completed after when this loop completes. Now we have to return, because this is the subroutine, and we have to end this subroutine. Now after completing this whole subroutine, the count will be placed in the register BL. Sorry, BL, no, not BL, DX. So after placing DX register, so in the next subroutine we will perform display. Okay, now in the next part we will perform display subroutine. So we are too long in this video, it's already 20 minutes. So before going to the next subroutine, I would like you to hit that subscribe button and like the video if you found this helpful, and share among your friends. So let's go to the logic, how to print in the screen. Suppose the count has become the 2. Now before displaying to the screen, we have to convert this number into ASCII value. For that we have to add 30. So if we display 32 in the screen, it will appear as 2. So we have to display ASCII value. But in case if the count is of two digits, suppose it is of 25, then how will you perform this? For that we have to do something. At first we have to separate this number. We have to separate 5, add 30. We have to separate 5, add 30, keep in stack, that is 35. Now we have to take out 2, add 30 and keep it in the stack 32. Now during the time of display we have to perform pop. Now before we are doing the push operation, now we have to perform pop operation. And I think you are familiar with the stack. It will pop from the for last in. So it works in the last in first out principle. So it will pop this 32 and display. It will display this 32 as 2, and it will display 35, it will display 35, and 35 will be displayed as 5. Okay, if you display this 25 directly without changing into the corresponding ASCII value, then some random character will be displayed. So this is the logic how you will convert the character into ASCII value. So this is quite easy. Now the main part is how will we separate the characters or the numbers. For that we have the logic like this. For example, if you divide 25 by 10, what will happen? 10 2 is 20, 5 remainder. This is the remainder. Now again we can divide 2 by 10, 10 0 0 and 2 remainder. So the remainder consists of the separated character. So by performing the division with 10, we can separate the character. Okay, now you are familiar with the logic how to separate the number of the count, that is 25 into 2 and 5 or any other number into their different bits. So to perform that we have performed the division with 10. So how to perform division in 86? For that we have the instruction div divisor. So this is the operand, this is the single operand, but to perform the division we need two operand, one divisor and one dividend. So where is the dividend? So the dividend is placed in accumulator. So what are the accumulator in the 86? There are three accumulator: AL, AX and DX.AX. This is 8-bit accumulator, this is 16-bit accumulator, and this is 32-bit accumulator. For example, we are performing 10 divided by 25. This is 10 to is 25. This is the divisor and this is dividend. Divisor can be placed in any register. For example, we can place this in CX register. Divisor can be placed in any register, but there is a strict rule in the 86 that dividend should be placed in one of the three register, that is accumulator. So divisor can be placed in any register, but the strict rule is that dividend must be placed in accumulator. This is the one of the strict rule, so you have to follow this rule. Dividend must be placed in accumulator. And one next thing, suppose this is dividend, this is divisor. If the divisor is of 8-bit, dividend must be of 16-bit, and if divisor is of 16-bit, dividend must be of 32-bit. This is also the next rule of the 886. So if the divisor is of 8-bit register, then dividend must be 16-bit accumulator, that means this. And if the divisor is of 16-bit, then the dividend must be of this 32-bit register. Now let's take example div bl. So bl is divisor here. So what is dividend? Okay, let's this bl is 8-bit register, so dividend must be of, okay, this is bl is 8-bit register, so dividend must be of 16-bit accumulator. I think you guessed that. So dividend must be of 16-bit accumulator. So this does is ax divided by bl, and the answer will come in ax register. But here you can see the answer will be of two part, that is remainder and quotient. Okay, the remainder will come in AL register and the quotient will come in AH register. I think I am correct. So let me confirm that. Okay, sorry, the remainder will come in AH register and the quotient will come in AL register. So this is the remainder and it will come in AH, and this is the quotient and it will come in AL register. So let me devise the rule. The dividend must be of accumulator, and the dividend must and the divisor and the dividends will be taken as 8 bit, 16 bit, 16 bit, 32 bit, and after performing the division, the remainder will come in AH register and the quotient will come in AL register. Suppose we are performing, this is the 8 bit division. Now suppose we are performing DIB BX. Okay, DIB BX. Then what it does is, this is the divisor. If divisor is of 16 bit, then dividend must be of, this is the dividend must be of 32 bit accumulator, that is dx dot ax. Now we have to divide it with b. Okay, the quotient will be in ax register and remainder will be in dx register. This is how you will perform the division operation in 886. Now the division is over. Now let's learn how to write the actual program. The video is already too long, so let's write quickly the last subroutine to display. It is display proc. Now this is the subroutine we can use for. Now we have to divide the number with 10 so that we can separate it into the different digit. So for that we have to set the divisor as 10, that is 0a. So let's make divisor mob bx comma 0 sorry cx comma 0 0 0 sorry 0 0 a. Yes, this is divisor. Now in our previous video we have obtained the count in dx register. So dx consists of two parts, dh dl. Suppose the count was 25 then the dl consists of 25 and dh consists of 0 0. Now as I have already said, and during the division operation the dividend must be in accumulator, but we have the dividend in dx register, so we have to place that in accumulator. For that we have to use the 16 bit accumulator, sorry 32 bit accumulator, because the divisor is 16 bit, so the dividend must be 32 bit, that is dx ax. Now we have to put this value in ax register. For that let's place this dl part into al and ds part into ah. For that we can do mob al comma dl and mob ah comma 0 0. So this is the dividend ax. Now our next dividend dx will be initialized later. You will know why this is initialized later. Now we have to keep the counter of the stack operation, mob bx comma 0 0 0 0 h. This is counter for stack operation. We have to perform some stack operation that is we have to push the characters into the stack. So we have to keep the counter so that we can know how many times we have pushed, so that we can pop us that much time during display. So we have to keep the counter. Now let's set this dx. This is another dividend. Now let's perform the division, actual division here. dib cx. dib cx means this is the divisor and the dividend is dx ax divided by cx. So this is the 16 bit, this is the 32 bit. So this is according to our rule, and the answer will come in dx ax. Okay, dx ax. Here dx will get remainder, ax will get quotient. So suppose we are performing 25 divided by 10, which is 10 to is 25. This is the remainder which is placed in dx register. Let me separate it. Now we have to increment this by 30 so that we can convert it into ASCII. Sorry, I forgot to tell you about the ASCII. So the ASCII, corresponding ASCII will be differ by 30 bit. So if you want to display, if you want the ASCII of 0, that is 30, 1 31 and 5 35, it moves on. So the ASCII value differs by 30. Now we have to add the remainder, that is this part, by 30. Add by 30. So we have to add, sorry, add dx with 30h. Now we have to push dx. Suppose this is the stack, we pushed dx, that is 35. Now we have to increment bx register because we have performed one push operation, so we have to increment this counter so that we can later on pop osmosis that time of the counter. Now we have to check this value. This is placed in AX register because in next division that will be 10 0 2, because in next iteration or next division this AX value will be 0. So this indicates the ending part of our division. That is, when the AX becomes 0, we have to end this division and our count is our odd is completed. That is, suppose we are performing the performing division on 25. So if the AX becomes 0, then it indicates that the division operation is completed. So we have to compare AX with 0 0. If it is not equal, then we have to perform division again. So let's put the label up, and the label up should be placed in this part. I will describe this part in some moment. If it is not equal, then it will move up. If it is equal, then we have to pop continuously. So in next iteration 2 will come out. We will add that 2 with 30 and push it in this part. So the counter becomes this is the counter, so the counter becomes 2. So let's place this counter bx into cx so that it becomes easy to perform looping. 2 So this is used just to make the looping part easy. We can make the counter is in any register, but if we keep the counter in CX register, then we can use the loop keyboard to loop that part. Okay, this we are moving the counter in CX just to make the looping part easy. Now if you are watching this video carefully, then you might wonder that why I am keeping this level up in this part and reinitializing dx as 0 0. Okay, let me explain that. So the dx is the part of the dividend. That is, this consists of this is ax and here is 0 0 0 0, which is dx. So if in the next part the dividend is 2, this is the part of ax, and we have to place dx as 0 0 0 0 again. So in the first loop dx has incremented or changed to value 5. In the next loop we have to make the dx again 0 so that we have 2 here. Otherwise this will be 0 0 0 5 and this will be 0 0 0 2, and it will affect our result. So that's the reason why I placed the label up in this part and reinitialize dx register. So now we are about to end the program. Now this is just to make the loop easy. Now we have to perform display part in the screen. For that, now For that we have to display character by character. So we have to use 0 to h. So let me explain that first. So at first we have to pop this part from the stack, and it will be of one character and display that. So we have to use 0 to, otherwise this is used for character, otherwise we can use string, but in this case we are printing character by character, so we are using 0 to. So let's do mov ah comma 0 to. Now we have to pop dx and int 21h. What earlier I have said, while performing display, the character which we have to display should be in DL register, but after performing the pop dx, the required character, that is 32, will be in dx register, but dx consists of dh and dl, so the required 32 number will be in dl register, and the dh consists of 00. So this will make our work. Now after performing this, we have to do looping, because we have to pop this again, so we can use loop and the label, suppose x1, and the labels will be placed here. Okay, now after performing this loop, okay, let me explain this. This loop is shortcut for the decrement and checking 0. Before earlier program, maybe we have performed the looping part, and in that I have decreased the counter and checked if the counter was 0. So if we place the counter in cx register, then we should not, there is no necessary to perform that these two operations separately, just this loop will do that work. Now the counting is over and displaying part is performed here, so this part will display. Now this is the subroutine and we are at the end, so we have to perform ret return and display in p. So in this way the program ends here. If you want the code of the program, then I will put this GitHub link in description. So this is the program to count the vowel from the string and display in the screen. So that's not for today. If you like this video, then please I request you to subscribe and like and share among your friend. This is one of the important aeiouAEIOU question, and it will, after learning this question, you can perform other programming also. So have a good day, best of luck for your exams.